Okay, so this is problem number 1 in the practice exam, but it's also problem number 619 on the textbook, right? So it's a truss problem, and it asks you to determine the force in each member of the truss. And I added a note on the practice exam to solve it using the method of joints, because I want to try both methods. For number 1, I want to try method of joints, and for the other problem, method of sections. So in this problem, we want to determine the force in each member of the truss. We have two forces already acting, two external forces with magnitudes of 8 kilonewtons and 12 kilonewtons. We have two hinges, so these are our supports, which are hinges. And the hinges are fixed to the ground, so that means only X and Y reactions, but since they're hinges, no moment reactions. Okay? So we have a problem like this. It's a truss problem. It's a little bit more complicated than the ones we've done in class. It has more members. But if you see a truss problem, I would say, what do you think is the first step you can take?
Find a global equilibrium, right?
Okay, yeah. You can try to draw a free body diagram in order to find the support reaction. So normally, if this were a typical problem, that would have been your step number 1 to draw a free body diagram. And your step number 2 would have been to apply the equations of equilibrium to find the reactions. Now, in this particular problem, we're not really cutting it into sections. We're actually going to use the method of joints. So when we use the method of joints, you'll see that we don't need to find all the reactions first. We can actually skip these first 2 steps, because for the method of joints, we still need to draw free body diagrams for each joint individually. So when we're doing that, we can find the reactions if necessary. But in this case, we're not going to need that, okay? So for this part of the problem, we can actually skip these first 2 steps. Now, when you're dealing with a truss system, there are special types of members that we can identify early on to make our work easier. Does anybody remember what those members were?
The zero force member?
Exactly, the zero force members, right? So in this case, can you identify any zero force members?
Well, let's start with CE.
CE? Okay, why CE?
There are 2 collinear bars, and then that one's at a 90-degree angle.
Exactly. We have 2 collinear bars, and that's really all we need to know. If we have 2 collinear bars, no external forces, then any third bar added to this joint will have 0 force, because whatever force this exerts, there won't be anything else to cancel that vertical force. So yeah, CE is a 0 force member, and I think that's the only one in this problem. So far, that's what we have. Any questions so far?
What about FB? Would that be a zero force member or no?
I wouldn't call FB a 0 force member, because we have 2 additional bars. So if this were to have any vertical force, this bar can cancel it out. So CE counts because we only have 1 collinear pair, so two members, and then a third one that's alone. In this case, we have the 2 collinear pairs, but we have an external force. And then we have 2 more members. So that wouldn't count as a 0 force member. Okay?
Okay.
If you're in doubt, then just ignore this part, and you'll find the 0 forces when you take your free body diagram at the joints. So I'm going to write step 3, but it's kind of a conditional step. Find the 0 force members. And finally, we can start our problem. So we're going to solve this problem using the method of joints. So for the method of joints, you want to draw a free body diagram for each joint. And in this case, you always want to start with the joint where you have the most information and the least number of unknowns. So in this case, which joint would you guys choose?
B.
D?
Oh, B.
B? Okay, so why B?
We have a force at B.
Mm-hmm.
And also we have the hinge have a force right there.
Yeah.
Okay.
So that can work, My only problem with that is that you're going to have this vertical external force, but then you're going to have two vertical components from your bar. So you'll have two unknowns when you take sum of forces in the y direction, right? If you take sum of forces in the x direction, again, you'll have this unknown. And even if you did solve for this hinge reaction, you'll still have two more x unknowns. So for B, I would say this would leave me with more unknowns that I want to solve. Okay? So I'm going to try with joint D. Okay? So if we look at joint D, we have one external force, and that's completely in the vertical direction. And then we have only one member producing a vertical reaction, which means that we can use our sum of forces in the y direction to find that force member, that force on member DE. Okay? So let's do that. Any questions so far? All right. So let's start with a free body diagram about joint D. We have our joint. I'm going to draw my x and y axis. And it seems here that I have a vertical force P2 directly downward. So I'm going to draw it here. And we know that P2 was equal to 12 kilonewtons. Now, these bars can only exert tension or compression. That means that whatever force they exert will follow the general direction of the bars. Now, just by looking at this system, we have a vertical force in the negative y direction. So, do you think bar DE will be in tension, which would be pointing upwards, or in compression, which is pointing downwards?
It'd be in tension.
Exactly. Exactly, in tension. So we have a force from D to E, and because the x component of this force is in the negative x direction, do you think bar CD will be in tension or compression? Tension will be to the left, compression will be to the right.
Compression.
It'll be in compression, right, to cancel it out.
Yep. That's right. And if we get our directions incorrect, then that's fine, because we'll just get a negative value, and from there we can say, okay, our direction was wrong. We can just fix that arrow. All right, so we have the system. Now we can apply the equations of equilibrium to solve this system. We already have a known value in the y direction. So I'm going to start with my sum of forces in the y direction. So I'm going to say sum of forces in the y direction equals 0. And then if I look at my forces in the y direction, I have this 12 kilonewton force that's pointing downwards, so negative 12 kilonewtons. And then I have the y component of this force. Now they didn't give us an angle, but they did tell us that we have 1 meter in the horizontal and 2 meters in the verticals. Okay, so if we have 1 meter in the horizontal and 2 meters in the vertical, using geometry, we know that the hypotenuse can be found using Pythagorean Theorem. So the hypotenuse would be the square root of 1 squared plus 2 squared, which is just the square root of 5. Now, why do I want the hypotenuse? Because I can use it to find my components using the slope method. So in this case, we're not going to use angles, we're going to use slopes.
Okay.
Go ahead.
Yeah, I'm good.
All right. So we have, in the positive direction, we have the y component of this force dE, which should be equal to the force dE times the slope component for the y, which should be equal to the y component in the triangle divided by the hypotenuse. In this case, 2 divided by root 5. And this should be equal to 0, because sum of forces in the y direction equals 0. All right? So far, any questions? All right, so sum of forces, oh, sorry, go ahead.
Like, if you use use angle, you will get the same answer, right?
Yes, if you use the angle, you can get the same answer, so it doesn't really matter. I try to use slopes when I can, just because it's easier for me, but if it's angle is easier for you, then just do it that way, okay? So here we have only one unknown, so we want to solve for force dE. That should be equal to 12 divided by 2 multiplied by root 5. Okay? So 12 divided by 2 multiplied by root 5, how much is that? I get here about 13.4 kilonewtons, right? So I'm going to write 6 times root 5 kilonewtons, which is approximately equal to 13.4 kilonewtons. Our answer is positive, which means that we assumed this direction correctly. Now, you guys knew that it was going to be positive anyway, but just to have a little bit of confidence, then the answer was a positive number, so this direction was correct. Okay? So we found this FDE, which is approximately 13.4 kilonewtons. Now, since the problem asked us to find all the forces and all the members, then we already have that force, FD, 13.4 kilonewtons. So that's one part of the problem. Now we can find force CD by applying the equations of equilibrium in the x direction. So force in the x direction equals 0. In the x direction, we have a positive force CD, which is our unknown. And then we'll have a negative x component of this force DE. So minus the force DE, which is 13.4. I'm going to write 6 root 5, just so it's a little bit easier to do the math for me. So 6 times root 5 kilonewtons. But that's only the force in the diagonal direction. If I want the x component, I want to use the slope by taking the x component of the triangle and dividing it by the hypotenuse. So in this case, it would be 6 root 5 multiplied by 1 over root 5. Those are all my forces in the x direction, so all of this should equal 0. We only have one unknown, that's force CD, so we can just solve for that force. Notice that this goes to the other side, so 6 root 5 divided by root 5 is just 6 kilonewtons. So we found that force CD, which is equal to 6 kilonewtons. Any questions with that step? So it's a little bit easier for me to write 6 root 5 just because the root 5 is going to cancel out. But if you don't have time for that in the test, that's fine. Just use 13.4. Okay? Your number may be a little bit off due to rounding, but it's okay. All right? So we found all the forces acting on joint D. Now, method of joints, we're going to have to go through each and every one of these joints. So if we already have all the forces acting on joint D, then we can jump to joint C. So I'm going to go with a free body diagram on joint C. On joint C, we already determined that this was a zero force member, so we don't have to include it. And then we have two forces in the horizontal direction. We already found that force CD was a compressive force, right? It was in compression. So if force CD is in compression for joint D, it also has to be in compression for joint C. That means that my force CD will be acting towards the joint. So force CD, which we already know is 6 kilonewtons. There is no force in member CE because we already determined it was a zero force member, but we do have a force for member CB or BC. Now, if this is pointing towards the left, in which direction will the other force be pointing towards?
The right.
Yep. So we have a force from B to C pointing towards the right. Now this should be a very simple one, right? Sum of forces in the x direction equals 0. We have a positive force BC and a negative force CD, which is equal to 6 kilonewtons. And all that should be equal to 0. So So that one's an easy one. So force BC equals 6 kilonewtons. All right. So we found another one of the members. Okay. So going back to our diagram, we found joint D. We already solved for all the forces for joint D. We already solved for all the forces for joint C. Now I can jump and maybe try to find the forces for joint E. So I follow the same process again.
Hey, good evening, everybody.
Hey, how's it going?
What's going on? I got a quick question before you start the next one.
Yeah, go ahead.
Okay, so to get started with the method of joints, we start with the joint that has a force on it, right?
Yeah.
So are we're doing the moment about G?
Well,
We start with that, or we start at joint D?
we didn't do the moment about G because for this problem we decided to skip finding the reaction forces because we already have a joint that we can solve without having to find any of the forces. Yeah.
Okay, cool.
Okay.
Cool. All right.
So is this Miller?
Yes.
All right.
Keep going.
So good. So we chose joint D because we have an external force in the y direction and only one component in the y direction, so we could solve for it quickly. So we wouldn't have more than one unknown. Okay?
All right. Okay.
All right. So we solved for joints D and C. Now we can solve for joint E. Okay? And in joint E, let's see what I have. Da-da-dum. Got my X and Y axis. Based on this image, we already determined that this was a zero force member, so we don't have to worry about it, but we do have a force from D to E. We already calculated that force here. Force from D to E was 13.4 kilonewtons in tension. So if it's in tension here, in D, it also has to be in tension in E. So those 13.4 kilonewtons will be acting or pulling away from the joint. Okay. What other forces do we have? We have a horizontal bar, that's EF, and another diagonal bar, that's BE. So I'm not really sure where those forces act on, but I can more or less guess, right? I already know that I have a force with a negative y component here. That means that the y component for this one has to be positive. So that's just a guess, right? But I'm guessing that my force BE will be in compression. Again, if I guess that incorrectly, it doesn't matter because I can always get a negative sign and then just switch the direction of the arrow later. And then I have a force from E to F. I'm not really sure if it's going to be positive or negative, so I'm just going to assume that it starts in tension. And if I got that wrong, it's okay. If I got it wrong, I just get a negative sign. All right, so we have this free body diagram. We have one known force, two unknown forces. Should we start with the sum of forces in the x or in the y direction?
Y, I think.
All right, yeah, that's correct. We want to start with the sum of forces in the y direction. We know that sum of forces in the y direction equals 0. And for the y direction, we'll have the y component of this force. So that means my 13.4 kilonewtons multiplied by the slope. In this case, sorry, go ahead.
So the slope is, what's that? 2 over root 5, right?
Exactly, 2 over root 5.
All right.
And this is acting in the negative y direction, right? So I'm going to stick a negative sign to it. Okay? And then I have a positive component for my force BE. So I'm going to say plus my force BE, but I only want the y component. If you look at the truss diagram again, we have 2 meters in the horizontal and 2 meters in the vertical. So our triangle looks something like this, where you have 2 meters, 2 meters, and if you use the Pythagorean Theorem, this should be equal to 2 root 2. Okay? That means that my slope, doesn't matter if it's horizontal or vertical, the slope should be the same, just 2 over 2 root 2, or just 1 over root 2, whatever you prefer. So in this case, my slope will be 2 over 2 root 2. These are my only forces in the y direction, so this should equal 0. Okay? We only have one unknown, so we can solve for this force. Move this to the other side, then divide by this term. It should give us a force BE of approximately 17 kilonewtons. If anybody got something different, then just let me know. Okay.
That'll be in compression.
Exactly. And we already assumed that it was in compression, so that's why I got a positive value, right? If I would have assumed tension, I would have gotten a negative value here. Okay? So, we found our forces in the y. Now we can just skip to sum of forces in the x direction equals 0. Now in the x direction, I have the x component of BE, and that's positive, so 17 kilonewtons, times the slope, which is 2 over 2 root 2. This is a 45-degree angle, so the slope will be the same regardless of whether it's in the x or y direction. I have the x component of force DE, so again positive, so plus 13.4 kilonewtons, times the slope, which should be 1 over root 5 if I'm not mistaken. And I have my force EF, which is negative, so minus my force EF. Those are all my forces in the x direction, so all of this should equal 0. Okay? So, we only have one unknown, so let's solve for that unknown. Force EF equals, I got more or less 18 kilonewtons. Let me know if you got something different. It's in tension, but it's okay. We already assumed tension correctly, so we got a positive value. So we found all our forces for, go ahead. So we found all our forces for joints D, C, and E. Now we can jump to joint B. So that's basically a method of joints, right? You pick one, and then you start moving, trying to make sure that you can use whatever you solve for one on the other joint.
Is it okay if I write a list of the forces?
Yeah, that's
Okay.
perfectly fine. It's actually easier for me.
Okay.
Yeah. So go ahead.
So, like on our work, could we just like at the end of the problem, could we just list all of the joints instead of like typing it into the computer?
Yeah, that's perfectly fine.
Okay, alright, thanks.
Okay,
Yeah.
cool.
You don't have to type your answer on the computer. If you just want to, even if you just want to box them and just submit that, that's also fine with me. Again, this is our first online exam, so it's new for you guys, but it's also new for me, so there's always room for improvement, okay? All right. Go ahead.
I want to make sure I did it right. Anyway, so the time that we're going to have allotted for the test exam, is this going to be 60 minutes?
Yeah. And like the other exams, it's not going to be as hard as the practice exam. Or as long.
Okay.
Yeah.
All right.
If you have any problems, Miller, just send me an email. I'll be watching my email all day, so if you have any technical issues, just send me an email and we'll work to fix it, okay?
Okay. Well, the only issue I had was when I was trying to do, when I was trying to do the practice exam, when I entered in all of my, I entered in everything, like the full equations and everything, but it didn't give me an option to save them in. So
It should give you an option to submit. Yeah.
Professor?
Go ahead.
I mean, Caesar asks, can we see the practice exam after 12 a.m. in Blackboard?
Yes. Yeah, the practice exam will be there all day tomorrow, and the videos that I record today will be there all day tomorrow. If for some reason we can't finish it today before 8, then I'll just record the rest and upload them anyway tonight. Okay? So I'll just record them after my fluid mechanics session. Let's jump to joint B. Okay? And I'll have some announcements, but I'll say them after I finish this exercise. So for joint B, we have our force from B to C, which we already found to be 6 kilonewtons in compression. And yeah, this is joint B. We have a force from B to E, which we also found to be 17 kilonewtons in compression. Yep. All right, so we have this so far. We have a force from member BF. Now, because the y component for this one is negative, the y component for BF should be positive. And then, because both of the x components for these two forces are negative, then the x component for AB should be positive. Okay? So, this has a lot more forces, but it's actually not that hard to solve. Oh, and I also missed the external force, P1. Alright, so we have 5 forces here, but we can still solve because we only have one unknown in the y direction and one unknown in the x direction. So should we start with x or y?
The y.
Okay.
Oh, y.
Alright, sum of force in the y direction equals 0. Let's see, we have this P1 force, which is in the negative y direction, so negative 8 kilonewtons. We have this unknown force BF in the positive direction, so force BF in the positive y direction. And then we have the negative component for the force BE, so minus 17 kilonewtons, but we only want the y component, so we multiply by the slope, which is 2 over 2 root 2, or just the sine or cosine of 45 degrees. I think these are all our forces in the y direction. All of this equals 0 because of equilibrium. We only have one unknown, so we can solve for that unknown. Force BF should equal 17 times 2 over 2 root 2 plus 8, which I get to be approximately 20 kilonewtons. Got a positive value, which means that I assumed this direction correctly, so that's good. Now we can jump to the x direction. Sum of forces in the x direction equals 0. I have my unknown force AB, and it's positive, minus my force BC of 6 kilonewtons, and minus the x component of my force BE. So minus 17 kilonewtons. I only want the x component, so I multiply it by the slope. All this should equal 0. And then I can solve for my unknown force AB. Okay. I get that my force AB is more or less 18 kilonewtons in compression. Got a positive value, which means that I assumed this direction correctly. So far, are there any questions? No? Good. So we already solved our joint. Which joint was this? F? No. B. So we already solved for joint B. Now we can jump to joint F, and after that we should be done, because once we get to joint F, we'll find these two force members, so we don't really have to go through joints A and G, which are actually at the hinge. So now, for my final step, I'm going to solve for joint F. going to draw my free body diagram. For my joint F, I have my force from E to F. And did I find that force? Yes, I got 18 kilonewtons in tension. So I should have 18 kilonewtons in tension. What else do I have? I have my force from B to F, which I also found to be 20 kilonewtons in tension. I have a force from A to F, which I don't know, and a force from G to F. So the force from A to F is diagonal, and since this y component is pointing downwards, the y component of A to F has to point upwards. So I'm going to assume that A to F is in compression. And then I'm not really sure if my other force, well actually I do know, since all my x components are pointing towards the right, my final force, my force from F to G, has to be in tension. Okay? Again, don't stress out too much about assuming these directions, because if you assume incorrectly, you'll just get a negative value. So we have x, we have y, and if we want to solve without getting more than one unknown, I'm going to start with my sum of forces in the y direction, because I have one known and one unknown. So sum of forces in the y direction equals 0. I have a 20 kilonewton force in the negative y direction. And then I have the y component of this unknown force AF in the positive y direction. I have my force AF. This is the entire force. I only want the y component, so I want the slope. This is 1 meter in the horizontal, 2 meters in the vertical, so it will have this shape. That means that the slope should be 2 over root 5. Those are all my forces in the y direction, so this equals 0. And now I can solve for my unknown force AF. Force AF is equal to 20 kilonewtons divided by this slope, and I get that that is approximately equal to 22.4 kilonewtons. It's in compression, positive value. We assume the direction correctly. Now I can jump to my sum of forces in the x direction. In the x direction, I have an unknown force Fg in the negative x direction, so negative force Fg. I have a positive force EF of 18 kilonewtons. And then I have a positive component of my force AF. So plus my force AF, which was 22.4 kilonewtons. But I only want the x component, so I multiply it by the slope of the x component, which should be equal to 1 over root 5. Yeah, I think those are all my x forces, so all this equals 0. And now I can solve for my unknown force Fg. So I get approximately 28 kilonewtons. And those are all the forces for our bars. We found every single force. We know that this is a zero force member, so make sure you identify it, or maybe cross it out, or just find a way to identify it as a zero force member, okay? And that's it. Any questions with this problem?
Yeah, I got one quick question.
Yeah, go ahead.
We only have one zero force member in the entire frame.
Yeah, in this entire truss, we only had this zero force member.
All right. Cool.
All the others had forces that we calculated. Okay? All right. If there are no more questions, then let me stop this recording.